Hello and welcome to EMQ Office Hours. Today, we will be covering a few topics. We'll give you an introduction to MQTT. My colleague Josh Eastburn will be covering some IIoT concepts. And of course, as always, we are here to answer any questions you have, and we'd like to discuss your IoT workflows. So, that being said, we'll get started here. The chat is open, and also our Q&A. So again, feel free to jump in to interact. Um, and I'll get started here with our introduction to MQTT. I do have a couple slides here for you. And we try to because we try to keep this interactive. I won't PowerPoint you to death, but I think it will be worth it to have a few visuals here. So MQTT is a lightweight protocol with minimal overhead. It's great for devices that are resource restricted. Let's say they don't have a lot of CPU or maybe don't have a lot of memory. And so it's very good with bandwidth, especially compared to protocols like HTTP, because when MQTT, after your first session, you're able to reconnect very quickly without the tedious handshake involved in HTTP. HTTP has its advantages also, mainly because of its widespread adoption, right? So a lot of applications use HTTP, but it in the IoT world, MQTT is unmatched, especially when you need a protocol that is again lightweight. You need a protocol that has very frequent messages, but short bursts of messages. MQTT uses a publish subscribe model, and so in this model, the client is separated from the server, right? So all clients don't need to be directly connected to the subscribers. That MQTT broker, which is us here at EMQ, that MQTT broker sits in the middle and manages that connection between the publishers and subscribers. So in the case that you see here, we have some devices that are sitting um, on these are most likely on premise, right? Or maybe out in the field. These are sensors. Maybe sensors in a car, receiving car telemetry. These could be sensors within a factory, re, reporting the status of machine status or PLCs. And those devices are connected to our broker is very versatile, so it can run on premise, it can run on public cloud, private cloud, and can easily be deployed in many types of ways, and I'll talk about those in a second. And so what you're seeing here in this diagram is where our platform sits, right? Our platform again sits in the middle between those publishers and subscribers and effectively manages that connection. Um, we can with MQTT you can deploy different levels of quality service. Those three levels are at least once, at most once, and exactly once. So based on your needs, you can adjust that quality of service to make sure you're getting the message retention that you need. Um, Also. with MQTT, you have a feature called the last will, right? And just like in a person, right, is a last will is what you want to happen after your death. In this case, it's not after death, but it's after disconnection, right? So if a client disconnects, you can set a last will of what you want that message, what you want that payload, what you want that device status to be when it disconnects. For example, when a client disconnects, you may want to trigger an alarm. You may want to just deliver a message saying that, hey, this client has disconnected, triggering some type of proactive maintenance at that point, right? Because now you're the first to find out. And that's one of the great things about MQTT and why it's so popular in IoT is that real-time messaging. And that real-time messaging again allows you to be more proactive instead of reactive to problems with connecting, with disconnecting, and overall status and health. And so MQTT and our broker is very scalable. We have tested millions of devices connected and still been able to achieve sub-second latency. And so that's again one of the great features about MQTT. And so now that we have a basic understanding of what MQTT is, I understand that a lot of you are developers, and some of you have joined us and are part of our Slack community, as well as our Discord and GitHub community. And we appreciate your participation. So let's take a quick look at some of our deployment options. Very versatile in the deployment in that, and very lightweight. So all you need is a minimum of 2 cores and a 4 GB machine. The our broker supports CentOS, Debian, Ubuntu, and the Mac OS operating systems. So we are Linux based. As far as deployment options, many of our clients decide to use containers because it's easy to deploy in a very consistent way. So we do have a Docker image that you can download and deploy. In as little as 2 command lines, you can stand up your server. Also, we provide a Kubernetes operator. So you can deploy a fully functional broker in a Kubernetes environment in just minutes. And then also a Terraform, which allows you to deploy in the cloud of your choice in a very consistent and scalable way. And so whatever method you choose, we do support that, and we have some great tutorials online to help you walk through those steps. And so we'll during our office hours today, we will be posting some resources for you in chat, so to make sure that you're able to get to the information that you need. So now that we understand what MQTT is and some of our deployment options, let's talk about data integration because that's a huge part of the value here, and most of our clients, most of our customers are using some type of database, whether that be MySQL or um, Post Postgres, SQL, MongoDB, Redis. We do support those data integrations, and again, as little as a few clicks, you can set up that integration to be able to create the resource, create the rule, create the action that you want to happen when that rule is triggered, and of course, test that rule. And so, again, no matter what database you're using and other services, we make it very easy to integrate MQTT into your workflow. And we recently we improved our GUI and introduced what we call our flows, AMQX flows. And this REMQX flows, and here you can see a screenshot of that. Again, it's a very easy low code way for you to integrate those other databases and services that are important to you. And so you can see in this example where we have a rule that messages coming in are triggering some SQL functions here, and then passing that data based on the rules that you set to Kafka or Timescale DB. And so gives you a visual way to not just set up your workflow, but be able to visualize that in one place. Um, Giving you that unified management and monitoring. And so again, we are open to chat, Q&A, and so I have a question now for our audience is what is your experience? What is your level of MQTT experience? And again, we'll be looking for your answers in chat. Q&A is also open, and your participation we look forward to your participation, and that's how we will decide who will get that Amazon gift card is based on your involvement and your participation. I have a question here from Akshay. Thanks, Akshay. I'm looking I'm looking to deploy architecture for up to 10 million devices, constantly pushing energy data in DLMS format with an average of 15,000 TPS. In this case, how should the architecture look? But that's a great question, Akshay. And again, in this case, for one, we can handle that many devices connected. And what you would want to do is, of course, set your rules of create your topics of your MQTT topics of the data that you would like to send and receive from your system. So let me take a step back here. So, similar to the architecture here, those devices in your energy sector, and we do have customers that are pushing data for public for utilities, reading that data. So, if even if you are not natively using MQTT, we do have tools that can help with that translation to make sure that you are able to send and receive messages in the MQTT format. The average of 15,000 TPS, we can effectively and reliably write to the database about 10 times that reliably. So again, I think know that we can handle that. And I'm curious to know, Akshay, are you using a broker now? Are you using our broker?
While he's maybe
Oh,
working on an answer there, I'll jump in on this question also, and a couple of other things for the audience. We noticed that our chat's disabled, so if I don't even think you can try to put anything in there, but if you do have something that you want to comment on, feel free to just drop that in the Q&A, and we'll use that for whatever you want to share with us. So we did throw out a couple of questions. What you're hoping to learn from office hours is the one that we're kind of talking about right now. If you have any questions though about the basics of MQTT that Ernest covered earlier, feel free to drop that into Q&A also. But I feel like actually maybe there's a couple of things that come up or that come to mind in your question when you're talking about architecture. And one, which I think Ernest is addressing here, is if you need to do some kind of protocol translation, right? You're dealing with energy data that already has a specific format. So you'll have to take that into account in designing your system. And the IoT approach is typically to handle that stuff at the edge, right? We're trying to not have to push a bunch of data that's not going to be consumable by the rest of the system into the network core to then do data transformations there before being able to distribute it, because that really affects your scalability and then the performance of the data, right? Your of the system overall, I should say, because you're not able to consume that data at the edge where you might be serving applications, right? So there are applications at the edge that may need to use that data, and if you have to move it around and then move it back before you can do something interesting with it, that's going to depress the performance of the system overall. So Neuron EX is one of the tools that we provide that helps with protocol translation at the edge. It's designed to function as an edge gateway. There's lots of different options out there, of course, but that's typically where you would want to locate that particular function, right? So as the source of truth, let's call it, as possible. So you can turn that into MQTT as quickly as possible, meaning there's a short distance between where the data is actually sourced and when it becomes MQTT. Everybody's noticing my strawberry tattoo there, probably seeing it flashing up. This is thanks to my 4-year-old daughter. She tatted me up today. Um, but yeah, so if you can turn that into MQTT quickly near the source of truth, then the rest of the only needing to speak MQTT, right? That's what you're moving around the architecture in general. So that maybe addresses that one question. And whether we can handle DLMS, I'm not familiar with that format myself. I could talk about other ones, but that would be a conversation we should talk about with like our solutions engineers and see how we could handle that particular one. But that's certainly going to be problem number one. And then number two, the question of scalability, right? So 10 million devices with version 4 of EMQX, that was kind of our upper limit for an EMQX cluster. We've, like Ernest mentioned, we've now 10x that. So you could still comfortably handle that with one cluster, right? If you're just looking at performance on paper, right? What are the stats for EMQX? But there might be other reasons why you might not want to do that. For instance, 10 million devices probably takes up a lot of geographical space. So you may have devices in other parts of the region or the globe that you're servicing. And that would be a reason to consider breaking up the number of clusters or increasing the number of clusters that you have to service local regions, and then building some kind of bridging in between those clusters. And there are lots of different approaches to that. So balancing the demand, is one probably important factor to consider, because that's going to affect the latency, right, that you have between each of those devices and your EMQX broker. And having multiple clusters work together and across regions, those are things that we deal with all the time. And again, that's the kind of stuff you'd want to get into the details, or we want to get into the details together to figure out exactly how you want to approach that or where those might be located. Okay.
yes. So good point, Josh. I do want to stress again that please use the Q&A to interact.
Yeah, sorry about
And
that.
also, I want to touch on an important point of moving that data to the cloud, right? And that's that's one of the values that we bring is effectively moving that data to the cloud, not just making that data available, but saving you some money by by filtering what data is sent, right? So in some cases, you're collecting thousands of data points, and you may not need to send that every second. And so what a lot of our clients are doing is they're taking that data, filtering that data, and before it's sent to the cloud, um, having collecting that data and maybe sending every 5 seconds instead of every second. And again, what that does is that saves you some money because usually with cloud services, you're being charged not so much for your data that's already in the cloud, but moving that data in and out of the cloud. So you want to be able to do that effectively. And and speaking of cloud, we support just about every public cloud and easily integrate with cloud services. We're available in AWS Cloud Marketplace as well as Google Cloud Marketplace. And so we make it very easy if, let's say, you're already using those services. We make it very easy to use those credits if you already have them. Josh, it actually made us a popular choice. I've talked to several clients at the end of last year, in August of last year, when Google's IoT Core service was deprecated. Many enterprises ended up coming to us and needed to rapidly migrate, right? Because it didn't just stop support;
For
it went
sure.
away, right? But a lot of these clients, they were still using a lot of valuable cloud services from Google, including Google PubSub. And so we are compatible. And when I talked about data integrations, that's an easy data integration to set up with our system, is that integration with Google PubSub. And so make it very easy to integrate with your cloud services.
Getting back to Akshay's question, he dropped in some more information about what he's working on, and I'm going to put a link. Hopefully, you're able to see this in chat. If not, you should see it in the Q&A section. Um, I think we can see. Yeah, you should be able to see that as an attendee. So we do have a server estimator, right? So we drop this link in. This will show you, depending on the number of devices that you're trying to support, or the number of connections you're trying to support, I should say, and the transaction per second target that you have. So those are the kind of the two key performance metrics we use, or I should say performance targets that we use for deciding the hardware that you're going to need to support your EMQX system. So I put a link in there to that server estimator that is based on the version 4 performance metrics. So with version 5, you should be able to use even less hardware than that. But Akshay, for the metrics that you gave us, 10 million devices and 15,000 TPS, it looks like you'll probably benefit from beefing up your hardware quite a bit. If you're maxing out at about 400,000 connections, if I understood that right, then that is likely the limitation. Based on our server estimator, you'll want to add a few cores and a lot more RAM. But take a look at that yourself and plug in the numbers. You'll see it tops out at 1 million, but even if you set it at 1 million and do the calcs for that, it's still quite a bit more than what you're running right now. So that should make a big difference, but feel free to reach out. I'll drop in the link to our contact us page also, and we can schedule some time to go through your specific architecture.
I
Hey,
have you covered there,
you
Josh.
got it. Thanks, man.
Yes, yes. Good. And so not just our contact us, I dropped in a link to our Discord, our forum, our GitHub, and our Slack, because we all use different ways of communicating, and we want you to be able to easily interact with our team. And so there are some things that you may need to do in your setup to be able to support that amount of connections, because there are limitations within Linux system itself. We do have some settings that you'll need to change to be able to support that number of clients within the OS itself. But again, we provide full tutorials to help you walk you through those. And so make sure you're joining our forums. And we do have both a weekly newsletter, just covering some of the tutorials, blogs, and webinars that we have coming, and then we also have a developer newsletter that tends to be more focused on configuration and getting into the details of setting up your broker.
Yeah. So level one, to kind of recap this whole part, definitely understand where you want to process that data for maximum performance. When you know what your system targets are, you definitely want to understand what the minimum system requirements are for EMQX. That's going to be your number one limitation. And then there's this whole other world of performance tuning, right? EMQX can be a very complex system depending on how much data you're moving, the different kinds of performance targets that you have. If you're leveraging different integrations, then those are going to have their own performance requirements. And so yeah, there's that can get pretty deep, like Ernest mentioned, into even the way that your maybe your Linux network settings are set up. There's certainly a layer of configuration within EMQX that we can help with also. So those are, I'd say, the kind of the three principal layers that you'll want to think about initially. I'll drop in one other one because we've got some pretty good docs on performance tuning for those of you who are at that level.
And so we did have some questions, some answers, Josh, that I'd like to share with you from that came in through various channels. And last week we asked, "How are you using EMQX?" So I'll share with you some of the different ones that came in. It fell into a couple different categories. One of the most interesting ones that I found is monitoring livestock. And so we have customers, we have clients out there that are managing, in this case, cows. Had a very large ranch covering hundreds of acres, and so those cows, they of course migrate across many acres. They and so that what they were using MQTT was to monitor not just the location, but the movement of that livestock, um, feeding times when how often they're feeding, and even sleep patterns because based on movement, there's certain assumptions that are able to be made, and so gives bringing that farming world into the next century using technology. And in the same strain, and talking about farming, also with water efficiency. So with being able to monitor the temperature, the humidity, the moisture of the soil. We've had farmers that are able to monitor water usage across the farm. Again, making sure that they're adjusting their water levels based on the condition of the soil. So those were two interesting use cases. We have, I would say, in the last 2 years, we've seen a huge growth in connected vehicles, and not just from within the car itself, but starting at the factory. And so being able to monitor equipment within the factory while building the car, monitoring the telemetry in the car once it's built, and even managing the charging infrastructure, and handling the billing for charging. And so really the full life cycle of connected vehicles. So that was a great use case. And then one new one recently that came in is aircraft manufacturing. So we just landed a pretty big deal with a huge aircraft manufacturer and helping to proactively monitor their manufacturing, making sure that their machines, their devices are operating as expected. So thank you for sharing with us some of the ways that you're using our broker and MQTT. Let me see. We have another question here.
Yeah, this is more from Akshay. If you want to move ahead, I know you've got other stuff planned. He and I can keep talking in the background, or we can go live if whatever you want.
Okay. Well, let's actually, Josh, I want to make sure that I understand that you have some experience in IoT, in industrial Internet of Things. Could you tell us share with us some of your background there?
Yeah, absolutely. It's been a longer than I usually think. I guess we're going on like 20 years. But I was a
Mhm.
computer science graduate back in the day. Back then they were mostly doing, C++ and Java. C will never go away, and Java is going to stick with us for a long time. But I know all the cool kids are doing Python and stuff, which I've always liked better. But that's a different subject. My dad worked as a control systems integrator, so for manufacturers, mostly in the semiconductor industry, up in the Silicon Valley in California, doing things like manufacturing lines for hard drives, that kind of stuff. And so I kind of got involved in the family business, and then kind of took my CS background and moved into the world of physics and time bound processes, which is pretty crazy, right? When you think about, oh, I'm writing software that's going to control a heater or a pump or a tank or a giant fan or something like that, and make stuff happen in the real world. That's essentially what the automation and process control world is about. And so that's kind of how I got involved in it, sort of like interning with my dad, and then ended up doing work in the a little bit in semiconductor, also in biotech. Worked in biopharma for a while, petrochemical, sort of secondary chemical processing applications, with companies like Chevron and Dow and Genentech. Um, yeah, yeah, yeah. So that's in a nutshell.
Nice. So with that's actually pretty impressive. So you were almost at ground level as this because IoT is I would say a fairly new field in comparison,
Yeah.
and but growing rapidly. The technology is grow I would say cutting edge.
hmm
So we have IoT on one hand, and then industrial IoT. What's the difference there?
Yeah. I think the key difference, they're the same but different. Is that's what I'm gonna say. And the key difference is that in the industrial world, you're dealing with a lot of specialty equipment, because of the real time nature of what you're dealing with, right? Like again, you're physics bound. Um, so you're taking the real world real time measurements to make sure, and this is reason number two, that your process is safe more than anything,
Mhm.
right? You want your equipment to be safe, you want your people to be safe, and obviously you want product quality and all other kinds of metrics that come out of process control and automation. This could be anything from controlling an elevator that's going up and down, heavy equipment, nuclear reactors. I mean, it's such a huge industry, right? So all of those factors put some constraints on what you can do. The expectations are different, and also you're dealing with different quantities of data, right? Potentially, sub-second levels of data, but continuously, 24/7, because these facilities, they may not shut down, right? This is not, you might see this more maybe in the uh, in in other parts of IoT, right, where somebody has a battery operated sensor and it wakes up every few hours and it spits out some data and then it goes back to sleep. That's certainly part of industrial IoT as well. But you also have temperature sensors that are constantly producing data, tiny little devices, and you'll have thousands of them and constantly operating. So you're dealing with large quantities of data. You're dealing with a lot of legacy data and devices because these systems are very long lived. They're operating in hazardous environments, and so it's not so easy to just go out and change out a sensor, right? If that's what you've got
Mhm.
to work with, you have to find a way to integrate that with your system in order to, create the kind of the kind of monitoring, the or the kind of integration that you're typically going for with an IoT type of application. So that level of reliability and that long life cycle puts these other constraints, meaning you're dealing with, maybe antiquated network equipment. You're dealing with a wide variety of different devices, right? If you've heard of PLCs, that's like a basic control device. You may also have, PCs and servers and other things in there that you would see in other kinds of IT environments. But typically, you're not going to have control over them. That'll be owned by a different group. And so, if you're building an IoT application, if you think about something that you might write for a smartphone, or if you're, building a product, right, that's an IoT type of product like home automation or security, you may own that entire system end to end, right? You understand the device because you provided that to the user. There's like an in-home router, you own that too. You control all the network traffic, right? That's all yours. Not the case in an IIoT application. It's very heterogeneous, and you have to find a way to get all of that stuff to work together.
It sounds like that that could be a little bit intimidating. Where would someone get started if they wanted to get into IIoT?
Yeah. Yes, it is complex. That's part of the reason that you're just kind of hearing about it now in the last few years. That the industrial space in general is a lot slower to adopt technologies because of the reasons that I said before, right? They just don't have the flexibility to change things out. Ripping and replacing is even more expensive than in, your typical kind of IT application. But also because of security, physical security, and cybersecurity requirements, they really have to make sure that stuff is bulletproof. You have to design new versions of things to make sure that they can operate in, high temperature environments, acidic atmospheres, all kinds of crazy stuff, right? So and like for me, coming from a CS background, I had a lot to learn about physics in the real world. So it doesn't hurt to understand that layer of the application. In fact, I had let me bring this up. I had a graphic here. This is what's called the ISA 95 architecture. That's a very simple way of saying it. You might also see it called the Purdue model. But what this is a way of an older way now, but what is sort of the standard way, the traditional way of visualizing the network architecture, or the even the whole enterprise, right? But the layers of data and control within an industrial organization, all the way from the bottom, right? Sensors and signals, where you're taking those real world measurements and then moving that data up through successive layers and systems. So you'll want to understand something about each of these levels, right? And some people play across all of these levels, all the way, from the sensors level up to ERP integration. Certainly, world class, types of system integrators are taking on those kinds of projects. You may be in any of these levels. There's sort of IoT applications across the entire stack, and that's another thing to understand. But number one is, understand something about these PLCs, a programmable logic controller. You'll see people now trying to replace these with Raspberry Pis and other types of
Mhm.
sort of IoT friendly things. But all of this stuff still exists, and you'll probably be consuming data from a PLC, right? Maybe more than anything, since they're often the gateway to all of this stuff, the sensors and signal stuff. They'll be feeding into SCADA systems, supervisory. That's misspelled. SCADA. SCADA is a supervisory control and data acquisition system, which in sort of traditional industrial applications has been kind of the gateway to the rest of the enterprise, right? So all of the low level data would kind of move its way up through the SCADA, and then these higher level systems would consume that data or request that data from the SCADA in a traditional client server architecture, right? Think 1990s. That's where this stuff really came into its own. And MES is a manufacturing execution system, and that's going to basically organize the work of these lower levels into batches of work, right? We're taking orders from the ERP system, which is an enterprise resource planning system, something like SAP, and we're organizing that into batches of material that need to be produced, run plans, that kind of stuff. And then the MES is executing all of that stuff, driving through the SCADA. And then the PLCs are usually operating at a local area, right? They control a piece of equipment or maybe a line of equipment, a group of assets that are actually doing physical work, right? Through
Mhm.
sensors and whatnot. So understanding all of that, because that's what you're going to see out there, right? And this cuts across lots of different industries. But certainly, if you're working in the manufacturing space, this is going to be the language that people understand. So I suggest getting familiar with that terminology and with this architecture, because especially if you're on the front end of IIoT, one of the big questions people are going to be asking is, well, why shouldn't I be doing this, right? And maybe we can get into that for a future, but when you can map all of those same things to an IoT based architecture, right? Where here we're using EMQX as kind of the hub for all of that data, and we can bring in device and sensor data through gateways and whatnot into EMQX as MQTT data. What does that look like when you do that at scale? Is a term that was coined by Walker Reynolds of the 4.0 solutions community. If you've seen him out there, I highly recommend taking a look at that if you're interested in the IIoT space or Industry 4.0 space, as they're kind of used interchangeably, separate subject. But he introduced this concept of a unified namespace, UNS. And this is becoming a new architecture for IIoT, where instead of having this very stratified architecture, we're designing a common space, a common hub where all of that data feeds in and can be consumed by every other client, right? If we go back here in this architecture, data moves up pretty easily, but it's kind of designed not to move down, right? For security reasons, right? People who are doing the enterprise planning up at the top, we don't want them sending, control signals down to this layer where they might affect the process. Okay, so cybersecurity is still a concern that doesn't go away. But if you're trying to build applications and make a really smart organization, a really smart process optimization, you're trying to apply AI and machine learning stuff to what you're doing to improve your output, to have just a more interconnected process, right? Like products that can learn from their use and then feed that information back into the manufacturing organization to help it create better products and yada yada. There's a term called circular manufacturing, which also takes into account product sustainability, and that has a lot to do with taking data from the field and feeding that into the process, so you understand how your products are affecting the environment. So all of that is harder to do in this ISA 95 architecture because it's not designed for that level of kind of like bi-directional communication, if that makes sense. So
Yeah,
UNS,
so
sorry, go ahead.
so it sounds like Josh, and I just want to pull this out that when people ask, is this a greenfield or a brownfield technology? This is brownfield where you do not have to re-architect and have all new sensors, all new
Mhm,
devices.
mhm.
You can bring those older legacy devices into the future
Yep.
by using something as simple as a Raspberry Pi. And I thought that's what your temporary tattoo from your 4-year-old was. I thought that was I said, oh, he really loves
Coincidentally,
Raspberry
another kind
Pi.
of berry. Yeah. But yeah, you're right. And like I said, these since these systems are so long lived, you have to take that into account. Yes, there are greenfield applications that, where they're building a new factory and they're going to design from the ground up with this kind of architecture in mind. But by and large, 60-70% of the applications are going to need this, layer over there on the left, where you have gateways or smart PLCs that are MQTT enabled, which that exists now. Um, and that can take those legacy signals, turn them into MQTT, and integrate that into a unified architecture. Yeah, and then the whole goal there is I don't want to build a new plant. I just want to make my plant smarter, right? That's the goal that people are trying to achieve. And by understanding, the potential for making data, we could call it more democratized, right? It's more easily consumable. It's not segregated, or we use the term siloed, right? It's very siloed amongst different organizations, or because you have this stratified architecture. Um, yeah, by understanding that this is an approach that is possible now, right? Um, that basically what this does is it creates a common data layer for the whole organization, right? So whatever part of the organization I'm in finance, I'm in R&D, I'm in operations. Whatever I want to understand about the organization, I can build an application that taps into the UNS, consumes data from it, and then I just build the application on top of that. I don't have to worry about what's the protocol that this legacy SCADA system uses, or how do I communicate with these PLCs to collect data from all of them. No, EMQX and that UNS architecture that you build out, it takes care of all of that for you, and you just have nice, clean IoT or internet cloud ready data. So whether you're building applications for a factory, that's on site, which is what this is meant to show here, right? You've got two factories here, and then they're communicating to another EMQX cluster that's in the cloud, and that's giving you your global visibility, right? And so you can build applications on top of MQTT at any layer because it's such a friendly protocol, right? That's another reason that we like it so much. And yeah, that's really where if you're a developer watching this and you're like, what's this IIoT thing about? That's where you're really bringing the value, is by being able to introduce this new mindset, this new way of handling data, and making it so consumable by the organization. And then there's layers beyond that too. You see AI and big data and all kinds of stuff. Um, that becomes possible there. Without this architecture, it's pretty difficult to build applications at scale, right? They're clunky. You've got lots of protocols in there that just weren't designed to scale this way. And again, going back to your last question about what's the difference between IoT and IIoT, and I think this gets at it, right? Is you're constrained by all of this real world stuff and by the age of a lot of the systems that you're dealing with. Having an architecture that creates a nice abstraction over all of that stuff and still allows you to interact with it and read and write data, high frequency, low latency, that's really what is making IIoT possible. But this is kind of specific to that world of IIoT. So there's a lot of research to do there, and I can share some resources when we're done here for everybody who wants to dig into that more. We've put out some good white papers and stuff on this.
Nice, nice. Thank you for that introduction to IIoT. I think I learned a couple of things myself from you. So
Right on.
thanks for that. I will say that we're the world's number one MQTT platform for a reason, and part of that is one, our support. So you again, you can see in the chat there many ways to interact and get support from us. And also, I would say our innovation. We are the first broker to introduce the use of Quick, QUIC, over MQTT. So, which is Quick is the underlying the next HTTP protocol. And the reason for that is it's very effective, similar to MQTT, is very effective in environments where you have poor network connectivity, or let's say your network is bouncing, you're connecting, disconnecting, connecting, disconnecting. Typically, TCP/IP doesn't like that because of the handshake required when you establish a connection. But with quick over MQTT, that connection becomes more reliable and a little bit more graceful. And so, speaking of innovation, I do want to reserve some time for Brandon to share with us some of the latest features that we've added to our MQTT platform.
Thank you, Ernest. And thank you all for being here again. I really appreciate your time. Some of these key themes were covered earlier in the presentation, and for the sake of time, I won't revisit them. But just to name, upping our connection capacity from 10 million to 100 million, that was very significant. Which a lot more headroom than a lot of folks will probably need. But as we get more connected, it'll be really important. Another major area was the enhanced administration and then data integration hub or flow designer that Ernest had mentioned. But going back to the enhanced administration, we really wanted to take different aspects of management and make them more accessible. So adding in some specific features that had been requested for a long time, things like backup and restore tools, re-architecting gateway management frameworks, so you're able to manage each protocol more efficiently. And another one's open telemetry metrics that was added in version 5.2, but recently in 5.4, which is the current version, also added support for traces and logs. So in addition to things like Prometheus, we also do have that full stack for open telemetry. In 5.3, we also added user audit logging, which we didn't have previously, but now you'll be able to track, user changes and see how those things affect the system. Also in 5.3, which was the version before, things like RBAC and single sign-on will now be available to you as well. And for the integrations, some that I wanted to point to, again, this is for the Flow Designer. Our most recent was integrations with Confluent and Upstash. So Confluent being the fully managed Kafka instance. So, those aren't always the easiest things to set up. Do have a lot of running moving parts. So being able to leverage a service like Confluent would make that that experience more seamless. And then Upstash also has support for things like Kafka and Redis as well. And I know we're running on time here, so some of the highlights from 5.4 that I'll run down the list on real quick. So we do have new data bridge designs. So we now have connectors and actions or syncs. There's new routing store schemas. So by default, improves both the subscription and routing performance. Back to also LDAP and Azure ADP authentication, HTTP API for things like import and export of configuration of user data, support for loading sensitive authentication data for bridges or connectors from files. We added a bunch of new gateways and also a dashboard support for things like audit log management and license updates. So now enterprise license supports up to 25 concurrent connections, down from 100. So those are the ones that were the most recent changes to enterprise. And I, again, just skated over these. But this stuff is well documented. We do very frequent posts, both to press releases, blogs, as well as documentation and change logs. So I do encourage you to follow us in all of our social channels, whether Slack, Discord, to be able to, even our newsletter, to be able to stay up to date with all of the latest happenings.
Thanks, Brandon. And I know you didn't go through everything, but I'll mention one of my
Yeah,
favorites is integration of the open charge point protocol.
that's right.
Again, very important when it comes to managing your charging infrastructure, your connected car infrastructure, with which we've seen so much growth over in the last couple of years,
Hmm.
and I often attend many of the manufacturing conferences, and a lot of those are held in Detroit. So maybe I'll see some of you there. And again, as Brandon mentioned, we have so many. Our team creates blogs daily to help walk you through these types of integration. A lot of those are very technical, but because they're meant to walk you through step by step. And as Brandon mentioned, we did cut back on some of our connections for our free version, and but it is still fully featured, right? So you can try our broker, try all of our features, but the key there is that scalability, right? When it comes to enterprise scalability, being able to scale to millions, being able to reliably scale in your cloud or virtual environment. That's really where our enterprise and managed cloud versions, where the value really shines, is where your partner, and from deployment to management to security updates, we make sure that your broker is reliable and scalable. So, that being said, thank you for joining us for our office hours, our January office hours, and we look forward to interacting with you again in February. Thank you.